Hi, welcome to Marine Gurukul video series. Through this video, we shall try and take you through graphical representation of simultaneous observations, and we shall call it as plotting 1 because plotting 2 shall be on staggered observations. Before watching this video, kindly make yourself comfortable about the contents of our earlier videos on position lines and position circles. This video shall be using the learnings of earlier videos, especially in respect of position line by bearings, celestial position lines, PC by range, and PC by high altitude celestial observations. In case you have any doubt, please do revisit and rewatch those videos before proceeding with this one. Now I'm sure all of us are conversant with chart work wherein we plot position lines and position circles to obtain the vessel's fix. It's exactly the same way as in chart work. Only difference being in chart work we have the latitude and longitude scale printed on the chart. We have the compass roses to give us the directions, and hence we have everything available there, and we just measure the parameters on the respective scales and we do our plotting. In these questions, when we are talking of graphical representation without chart, then obviously we'll have to either use a graph paper or we'll have to do on a plain sheet taking a suitable scale. So let's run through the steps involved in solving these questions. First, we'll have to analyze the information that is provided to us to figure out adequate information so that we can get to know whether it is giving us two position lines or is it going to give us two position circles, or else maybe one position line and one position circle. Needless to say, as the title of the video suggests, both the observations have to be for the same time, that is simultaneous observations. From the information that we obtain, we identify for position line what is significant for position lines is we'll have to identify a position through which to draw the position line, irrespective of whether it's a terrestrial PL or a celestial PL. We'll have to identify a position through which to draw the PL and the direction of the PL. For position circles, we'll have to make effort to identify the center of the position circle and the radius of the position circle. Now, to be able to mark parallels of latitudes, meridians, and mark of positions and distances, we first draw one of the parallels of latitude and one of the meridians that we know in the question, and these ones drawn first act as reference for marking the remaining parallels of latitude and remaining meridians. To plot other parallels of latitude and distances on the plot, we choose an appropriate scale. Obviously, we should be choosing the largest possible scale in a given scenario. We know that the latitude scale or scale of latitude and the scale of distance are same. Why? Because 1 minute of latitude represents 1 nautical mile. To plot other meridians with respect to the reference meridian just discussed above, we need to find out what shall be the east-west spacing between the two meridians. Now this east-west spacing between the two meridians shall depend between the d long between the two as well as the latitude. Why? Because we know that meridians have maximum separation between them at the equator and they all converge at the poles. So the east-west distance between them we all know is called as departure. So when we plot the meridians, we'll use the scale that we have chosen and we'll separate the meridians by a distance equal to the departure in the latitude for which the plotting is being carried out. Departure is obtained with reference meridian and the meridian to be plotted from their d long and latitude. And which formula do we use to get the departure? It's the parallel sailing formula, which is departure upon d long is equal to cosine of latitude. Now, once all the parallels of latitude that are required are marked on the plot and also the meridians, then we can use them to identify on the plot the position through which to draw the position line and the center of the position circle. Now, once the positions through which the PLs have to be drawn or the center of the position circles have been identified, PLs and PCs can be plotted. As they shall be simultaneous observations, so the intersection shall give us the fix. Now, using the scale of the plot, the delat of the fixed position can, from any of the parallels that is plotted on in our plot, can be measured, and that delat can be applied to the latitude of the parallel from where it is measured, and that shall give us the latitude of the fix. Likewise, the east-west distance of the fix can be measured from any of the meridians which is plotted and identifiable, and using the same scale as the scale of distance, and this shall be the departure between the meridian from where it is measured to the meridian of the fix. This departure can be converted into d long using the parallel sailing formula, and once the d long is obtained, the d long can be applied to the longitude of the meridian from where the departure was measured, and that shall give us the longitude of the fix. So this way, the fix having been identified on the plot, its coordinates can be obtained in latitude and longitude. Let's apply our learnings to an example. In DR 50 degrees 10 minutes south, 140 degrees 40 minutes east, star X observation gave an observed long 140 degrees 36 minutes east. Azimuth 075 degrees true. At the same time, star Y meridian altitude gave an observed latitude 50 degrees 14 minutes south. Find the vessel's position. Now, before we proceed any further, it's important to identify the methods deployed for solving the site of star X and star Y. I'm sure we can all figure out that star X has been solved using long bicron, and in such case, the PL shall be drawn through dr lat and observed long. Direction of the PL perpendicular to azimuth. As far as star Y is concerned, it's a meridian altitude observation. So the PL shall be drawn through observed lat and dr long, perpendicular to azimuth, but in this case of meridian altitude, the PL shall be specifically east-west, and hence it will coincide with the parallel of latitude of the observed lat. Now, having identified the processes deployed for solving the sites, we proceed ahead with the plotting. We have the dr lat coming up on the screen. We have the observed lat now the d lat from dr lat to observed lat is 4 minutes south. This information shall be used to plot these two parallels with respect to one another. Direction of PL of X, as already said, it will be perpendicular to 075 degrees to the azimuth, so shall be 165 degrees to 345 degrees. Direction of PL of Y shall be east-west, that is 090 degrees to 270 degrees true, being a meridian altitude observation and solved by latitude by meridian altitude. Now we come on this side. We have this dr latitude, the parallel coming out here. Then we decide on the scale that we would like to use. So we'll use, as far as graph in the background is concerned, one big box as 1 centimeter. If without graph, we can take 1 centimeter as 1 minute. So the observed lat has to be 4 minutes south of the dr. So we go 4 minutes south, d lat 4 minutes south, and we draw the observed parallel of latitude out here. Now, in this case, the latitude that the meridian that we shall need would be the observed long. So we draw the observed long. It's drawn out here. Now we all know that for star x, the PL shall be drawn through dr lat and observed long, that is this point. And direction as already calculated as 165 to 345. So we have this PL for star x coming up here, passing through this point. PL for star y is going to coincide with the observed parallel of latitude. So here is the PL for star y, which you can say should have been drawn through observed lat and dr long, but since it's east-west, so it doesn't matter whether dr long is marked or not. Now the two PLs being for the same time, they intersect here. So this becomes the fix of the vessel. And what do we see? The latitude of the fix is same as the observed lat. And this distance is the departure of the fix from the observed long. So we see that the departure is 1.1 minutes east from the observed long. So we come this side for calculations now. Fixed lat is same as observed lat, 50 degrees 14 minutes south. Departure, read off from the plot using the same scale out here. From observed long to fix is 1.1 minutes east. We convert this departure into d long by using the cosine parallel sailing formula for latitude 50 degrees 14 minutes, and we get the d long as 1.7 minutes east. This d long we apply to the observed longitude, and that was 140 degrees 36 minutes east. When we apply a d long of 1.7 minutes east to it, our fixed longitude becomes 140 degrees 37.7 minutes east. So the coordinates of our fix obtained through plotting would be then 50 degrees 14 minutes south, 140 degrees 37.7 minutes east, and it's here that we have the fix of the vessel. I'll also take you quickly through same plot if it was done without a graph paper. It's the same plot, same steps. I don't think they need any further explanation because it's a repeat, but only thing is now the plot is being done on a plain sheet. And you can see how the plot is coming up. The two parallels have come up. We have the observed long meridian coming up. We have the PL for X. We have the PL for Y. We have the fix being identified here. We have the departure here, and then the same calculations as in the earlier discussion being carried out to get the coordinates of the fix. So if you do not have a graph paper, then your plot shall be somewhat like this. Please do not forget to declare your scale in the plot. It's very, very essential. So the whole idea of showing this one was that if you do not have access to the graph paper, you could have your plotting done this way, the way you see it on this particular slide, which is on display right now. One more example, using DR 12 degrees 20 minutes north, 180 degrees, simultaneous observations of two stars gave following results. Star X azimuth 220 degrees true, observed long 179 degrees 55 minutes east. Star Y azimuth 305 degrees true, intercept 3 miles towards. Find the vessel's position. I'm sure star X, which is a repeat as far as the process of deployed for solving it is concerned, has been solved by Cron, as discussed in the previous case also. So therefore, for star X, the PL shall be drawn through dr lat and observed long. Direction of the PL shall be perpendicular to the azimuth. Star Y, which gives us intercept, has been then solved by intercept method. The PL shall be drawn through ITP, intercept terminal point or intercept terminus point, and the direction shall be perpendicular to azimuth. Having identified the methods deployed and the positions through which to draw the PL, we can proceed further. We can see on the graph, we have drawn dr lat and dr long and assumed a scale out here. Obviously, these have been placed keeping in mind the question so that other meridians and other parallels of latitude, if required to be plotted, they have enough space to be plotted on the graph. Now, dr long is 180 degrees. Observed long by solving star x site is 179.55 minutes east. So if I have to plot observed long with respect to dr long, which has already been plotted, then the d long between the two, it's the d long between the two, which is 5 minutes west from dr to observed long. That means observed long shall be plotted west of the dr long, but the spacing has to correspond to departure. So we find the corresponding departure, and the departure is found to be 4.9 minutes west. We also identify the direction of the PL for star X, which is perpendicular to its azimuth, direction being 130 to 310. And likewise, direction of PL of Y, perpendicular to azimuth of 305 degrees true, and direction being 035 degrees to 215 degrees true. So now using this departure between the two meridians, we plot the observed long. So here is the departure to the west, 4.9 miles, and here is the meridian for the observed long. Now wherever the dr lat intersects the observed long, this is the point through which the PL for star X has to be drawn, and its direction is 130 to 310. So here is the PL for star X, which comes up on the plot. PL for star Y would be drawn through ITP. So first we draw the azimuth through the dr. Azimuth of star Y has been drawn through the dr. Now intercept is 3 miles towards, that means it will be 3 miles on this line towards the body. We mark off 3 miles here. This green line showing up here measures 3 miles. So this is the point which is the ITP. Through this point we draw perpendicular to the azimuth and we get the PL for star Y. Since both the PLs are for the same time, therefore this is where the fix is. We read off the d lat for the fix from the dr lat, which is 0.7 minutes south, and likewise we also read off departure, which is 0.8 minutes east of the observed long. Using this d lat and departure, we come on this side. We have the dr lat. We know the d lat of the fix from the dr lat, and we get the latitude of the fix as 12 degrees 19.3 minutes north. We have the departure of the fix from the observed long, which is 0.8 minutes east. We convert this departure into d long. So d long comes to 0.8 minutes east. So that means longitude of fix is 0.8 minutes east of the longitude, observed longitude. Observed longitude being 179 degrees 55 minutes east, the longitude of the fix is then 179 degrees 55.8 minutes east, and hence the coordinates of the fix are 12 degrees 19.3 minutes north, 179 degrees 55.8 minutes east. Now if you do not have access to the graph paper, the same plot shall appear the way you can see on a plain sheet here, and drawn to a scale that is chosen, and that's how your plot shall appear on a sheet in the absence of being plotted on a graph paper. Let's have one more example then. On 15th June 1992 at GMT 12 hours 05 minutes, the true altitude of the sun was found to be 89 degrees 55 minutes. At the same time, a point of land in position 23 degrees 26.5 minutes north, 001 degrees 15 minutes west, bore 320 degrees true. Find the position of the vessel if the sun passed north of the observer. Now in this case, the celestial observation shall not give us a PL because it's a high altitude observation with altitude of 89 degrees 55 minutes with a TZD is only 5 minutes. Therefore, in this case, the sun observation shall give us a position circle by the method that we have discussed in our earlier videos as PC by high altitude celestial observation. The second case is of a PL by bearing of a identifiable point on land, so that we are all conversant with. Now, first we need to get the GP of the sun to be able to get the PC, because when you have a PC by high altitude celestial observation, then the center of the PC is the geographical position of the body on the surface of the earth, and the radius of the PC is equal to TZD. And what is geographical position of a body? Geographical position of a body is linked to its declination. The latitude of the GP is same as the declination of the body, both in name and value and name. The longitude of the GP is related to the GHA of the body. If the GHA is less than 180 degrees, the longitude of the GP is same as the GHA, and the longitude carries a westerly name. If the GHA happens to be more than 180, then the longitude of the GP is 360 minus GHA, and the longitude shall be named east. We first, to be able to get the GP, we get the GHA of the sun and we get its declination. So we have this as the GMT. From the almanac, we start getting the GHA and declination. Then we have the increment for GHA and decorrection for the declination. We get GHA of sun and we get declination of the sun. From here, what do we infer? That the GP's latitude shall be north 23 degrees 19.9 minutes, same as the declination of the sun. And as the GHA is less than 180, so the longitude of the GP shall be same as the GHA, and the longitude shall be named as west. So I hope you are able to recall how the GP is obtained. Now what we have drawn on the graph is the parallel of latitude for the land, the point on land, which is 23 degrees 26.5 minutes north. Why? Because we see that the GP latitude is south of it. Now this is here that we are drawing the meridian for the point on land, which is 001 degrees 15 minutes west, and we know the meridian of the GP shall be to the east of it because its westerly value is lesser. So that's why they have been drawn, one right on top almost and other to the left part of the page. Now we have this, obviously is the landmass, the point on land whose bearing has been taken as to give us the second PL. Now we can, since the distances involved are little bigger, we can have a little smaller scale. 1 centimeter equal to 2 minutes or 2 miles. Now the land point to GP, DLAT is 6.6 minutes south. That means the parallel of the GP shall be 6.6 minutes south of it. And since we have chosen this scale of 1 centimeter equal to 2 miles, so this is where we have the parallel of latitude for the GP of the sun. Now we find out the D long from the point on land, this meridian, to the meridian of the GP, and the D long is 7.4 minutes east. That means meridian of the GP on this would be on this side. But to space them out, we'll need the departure. So the departure, using the latitude, we get departure at 6.8 minutes. So using the same scale of 1 centimeter is equal to 2 miles or 2 minutes, we come 6.8 miles to the east, minutes to the east, and we are able to plot the meridian of the GP. Where the meridian of the GP intersects the parallel of the GP, obviously this is the point where we have the GP of the Sun. Now we come to plotting of the PL and PCs. Now this is where we have the PL by bearing. This land point is bearing 320 degrees, so this becomes a PL of the vessel. Now we also know that the true altitude is 89 degrees 55 minutes. So TZD is only 5 minutes, which becomes the radius, 5 miles becomes the radius of the circle. So with this GP as the center and 5 miles as the radius, we draw the position circle, and this is the position circle of the vessel. Since this PC and the PL are for the same time, the vessel could be at the point of their intersection. So the vessel may be either at this point, that is point A, or maybe at this point, point B. Now, since the question says the Sun passed north of the observer, now Sun in this plot is represented by its GP. So if the observer is at A, then Sun is passing south of the observer. But if the observer is at B, the Sun is passing right north of it. So therefore, in this case, position A gets ruled out. The fix is then position B. So B is the fix out here. And what do we see in this case? That B lies on the same meridian as the meridian of the GP. So in this diagram, what do we see? This is the D-lat of the fix from the latitude of GP, and it's exactly 5 minutes south. So therefore, the latitude of the fix becomes 23 degrees 14.9 minutes north. What do we see about the departure? The fix lies on the meridian of Sun's GP. So departure from there is 0. Therefore, D long is also 0. And therefore, the fix long is same as the longitude of the GP of the Sun, which is 001 degrees 07.6 minutes west. And therefore, now the coordinates of the fix are 23 degrees 14.9 minutes north, 001 degrees 07.6 minutes west. So here in this case, we had the intersection of a PL and a PC. PL was drawn from a terrestrial reference and PC was by high altitude celestial observation. Just quickly a repeat of the same process on a plane sheet, same question. So just repeating it if you have to plot it on the plane sheet. Steps are exact repeat, the difference being that instead of a graph, the plot is being carried out on a plane sheet and the plot shall appear the way it's coming up. We have position A and B coming up. Then we have the fix also identified now, and it takes us to the position of the vessel. And this is how the plot shall appear if you do not have access to the graph paper. Then this is how you would plot your question. We quickly run through the last example. DR 00 degrees 4 minutes north, 179 degrees 57 minutes east. Two simultaneous observations. Star X azimuth 120 degrees true. Observed longitude 179 degrees 58 minutes west. Star Y azimuth 200 degrees true. Intercept 2 miles away. To find vessel's positions. I'm sure as far as methods are concerned, there is no discussion that should be required now. Star X by longitude by chronometer, star Y by intercept method. On the graph, you can see up dr lat and dr long coming up. And now to be able to draw the observed long with respect to dr long, we find the d long from dr to observed long coming up on the right side here, 5 minutes east. We convert this d long into departure, and departure also happens to be 5 minutes east. Then we identify the direction of the PLs. perpendicular to their respective azimuths out here. And now with the departure being 5 minutes east with respect to dr long, we mark off the departure here 5 minutes east and we draw the meridian of the observed long. Now through this point, which is intersection of dr lat with observed long, we have the PL for star x in the direction of 030 to 210, and you can see the PL of x coming up on the plot on the graph passing through this point. For PL of y, we identify the ITP first. So we draw the azimuth of y through the dr. Here is the azimuth in the direction of 200 degrees true. Now in this case the intercept is 2 miles away, so we mark off 2 miles in the opposite direction represented by this green line out here. So this is the ITP in the away scenario. Through this perpendicular to azimuth we draw the PL, and this is the PL for y. Where the two intersect, this point is the fix of the vessel. We read off its D-lat, it's 0.3 minutes north of dr lat, and its departure we read off here. This departure is 0.2 minutes east of the observed long. We apply this D-lat to the latitude of the dr lat, and we get the latitude of the fix as 00 degrees 04.3 minutes north. Departure from observed long to the fix is 0.2 minutes east. We convert this into d long, and being almost at equator, they are both equal. We apply this d long to the observed long, which is 179 degrees 58 minutes west, and we get the fixed long as 179 degrees 57.8 minutes west. So the coordinates of the fix out here are 00 degrees 04.3 minutes north, 179 degrees 57.8 minutes west. The same plot, if done on a plane sheet, would appear the way it is showing up on your screens now. So I'm sure with these 4 examples, you would have gained confidence to be able to plot simultaneous observations, both using graph paper if accessible, and at the same time, in the absence of graph paper, be able to plot same on a plane sheet. Now we come to end of this plotting 1, that is the graphical representation of simultaneous observations. Hope the video serves the purpose it is intended for. If you have any feedback or you need any further support, please feel free to write to us at marinegurukul@gmail.com. Request you to circulate this video as widely as you could so that more and more people could benefit from it. If you like our effort, please like the video, share your comments, subscribe to the channel. Thank you very much for watching Marine Gurukul video series. Thank you very much.